Welcome to Brain Vision.
In this example, we want to calculate how much helium, in terms of the mass of helium, is in a blimp with a volume 5,400 meters cubed, an absolute pressure of 1.1 times 10 to the 5th pascals, and a temperature of 280 Kelvin. So to do this, we're just going to be applying the ideal gas law, which is PV equals nRT. Now this relates the pressure, volume, temperature, and amount of an ideal gas. In this equation, though, you can see that we're dealing with the number of moles right here, little n, but we actually want to be working in terms of mass. So we're going to have to remember how to convert from moles to mass. So the total mass of our gas is going to be the molar mass, big M, of helium times the number of moles of helium, N. So if we just substitute this, or if we solve for M here by dividing both sides by the molar mass, we can substitute this in for the number of moles into our ideal gas law, and then solve for little m. So let's go ahead and do that. So PV equals little m over big M times RT. Then we're going to divide both sides by RT and multiply both sides by big M. And we will be able to solve for little m. So the mass is going to be equal to the molar mass of helium times the pressure times the volume over the ideal gas constant times the temperature. Okay, so these are all knowns now. We'll have to look up the molar mass of helium, but that's not too bad. We have the volume in meters cubed. We have the pressure in pascals, the temperature in Kelvin. R is a constant, so we just need to figure out what the molar mass of helium here is. And for that, I will be using a value of 0.004 kilograms per mole. You might have seen this in units of grams per mole, or something like 4 U, which is exactly the same, where we just converted to kilograms by moving the place 3 times back. Okay, so if we plug all of those values into our equation here, we will get that the total mass of that gas comes out to be 1,020 kilograms. All right, so we just showed that given the volume, pressure, and temperature of a gas, we can solve for the mass of that gas using the ideal gas law.